Hello, this is Mr. Bainey, and this lesson is 7.1, Modeling Linear Relationships. The essential question is, how can you model linear relationships given limited information? So let's try this explore activity. A department store offers a frequent buyer's card to earn rewards for purchases customers make at the store. Each transaction is worth 12 points. Customers automatically earn 25 points when they sign up. So we're going to write an equation for this function that gives the card value based on the number of transactions that have occurred. So units that are associated with the variables in this function. So when we look at our rate, this is going to be important. It says each transaction is worth 12 points. And so that means it's 12 points per transaction. So X, we're going to look at, and they're not going to use X in this case, so let's get rid of that. Let's talk about independent and dependent variable. So our independent variable is going to be the number of transactions, and our dependent variable is the number of points. So before I'm writing down some of these responses, it'd be good to pause it just so you can try to think about it a little bit before, and so you're not just listening to me give all the answers every single time. You want to be able to put some thought into some of these because this is something that we're continuing, that we have been practicing and continue to practice, is identifying the variables, writing the equations, knowing how to interpret both slope and y-intercept in these word problems. Okay, so part B, we're going to complete the verbal model, or just write it in words for this function. So the card value, and that's going to be in points, is going to equal the initial value in points, and we're going to add something to this, and it's going to be the initial value is the 25, right? So let's make sure we got our numbers straight here, just so we can align this with what the problem is in the beginning. So now we need to calculate how many points are earned from each transaction. So it's going to be the number of transactions times, and how much do we get for each transaction? We get 12 points per transaction. Okay, so to write this function rule, it's going to be C of t. So C is card value, t is the number of transactions. It tells you that right here, t is the number of transactions here. Card value is C. We're going to have 25 plus 12 times t. T is already there for us. So for each 100 points, the customer receives a gift certificate. How many transactions will it take for the customer to earn the first gift certificate? So one way we can do this is an old-fashioned guess and check, right? We could do that. One way, another way is also, let me just show the guess and check really quick. What I mean by that is we can just plug in 1 and figure out how many points the card value will be at one transaction. And so C of 1 is actually going to be 37 once I calculate that all out. C of 2 is going to be 25 plus 12 times 2. So 12 times 2 is 24, plus 25 is 49. And so I can keep going. Let me skip a couple. Let's do C of 4. And I get 25 plus 12 times 4. So multiply first and then add 24, and that'll be, what is that? 48 plus 24 is, looks like 72. So I know it's going to go up by 12 every single time, and I'll realize that it's not going to reach 100 until we do about 7 transactions, it looks like. Okay, so I'll let you finish that up if you need to. Another way is we can figure out if we want the card value to be 100, I'll change my C of t. I'll change that to 100 and set that equal to 25 plus 12 times t. And we're, in this case, solving for t. It says how many transactions. So we're solving this for t. If I subtract both sides by 25, I want to get rid of this 25 that's right here. I get 75 equals 12t. And what you'll notice is this doesn't go in evenly when I divide 12. So let's divide, and I'm going to get something like 6 point something, right? 6 times 12 is 72. So really it's 6 and a quarter, right? Or 6 and 3/12, which is 6 and 1/4 if I reduce it. So this means 6 and 1/4 transactions, which makes no sense. So this means that it would have to be 7 transactions. Okay, so here I show you two methods to answering this question. Part E, what's the y-intercept for this linear function and what does it represent? The y-intercept is, I'm going to write b because it's our universal variable that we use, it is 25, and this represents the initial card value. It's the card value when the customer first signs up. Okay, let me just double check, make sure that's correct. Yep, 25. And what's the slope for this linear function and what does it represent? So the slope, we use m, that is 12, and it represents the points per transaction. Slope is always going to be a unit rate or a rate. So it's going to be points per transaction, or miles per hour, or meters per second, or gallons per minute, something like that. Okay, on this page 302, there is an example where you can go through the steps. If you look near the bottom, analyze information, formulate a plan, solve. This is a good example to really go through if you're just looking at trying another example that's structured for you. So I'm not going to do this. I'm going to go straight to the your turn. That is on page 303. And this here shows a sandwich shop that sells sandwiches for $5 each and bottles of water for $1 each. The owner of this shop needs to earn a total of $100 by the end of the day. We're going to write a linear equation that describes the problem and then graph it. Make sure to label both axes, then use the graph to determine how many sandwiches the shop must sell if no waters are sold. So the first thing it tells us to do is write a linear equation that describes the problem and graph it. Write the equation and graph it. The last thing is to determine how many sandwiches if there's no waters. Okay, so our unknowns really are, if you look over on the graph, it has us use W and S. And so our unknowns, if we're gonna make $100, and this shop is selling sandwiches and waters. The unknowns are the number of waters sold, and S is the number of sandwiches sold. Okay, again, we know that this shop is going to make $100. We know how much each one is. We just don't know how many of each one are going to be sold. So the way we're going to write our equation is we want the amount earned from the water sold plus the amount earned from the sandwiches sold, and that's going to equal our $100. Okay, so the amount earned from water sold, if it's $1 per water, it's 1 times W, right? So if we're selling 30 waters, that's going to be $30 earned. And then for sandwiches, it's $5 each. So it's going to be $5 times the number of sandwiches. So as an example, if 5 sandwiches are sold, that means $25 is earned. And then we're going to graph this. So one way to do it is we can find intercepts. We can plug in, right, and figure out what sort of values we get. So let's go ahead and plug in. And it doesn't matter which one we start with. So if I say something like 10 sandwiches are sold. 10 sandwiches would mean $5 for every sandwich is 50 bucks. And then that would mean there would have to be $50 in waters, right? Which is 50 waters. And that would make $100 if 50 waters and 10 sandwiches were sold. So the y-axis, before we start graphing this, the y-axis is going to be the number of waters sold. So I'm just going to write number of waters. And then for my x-axis is the number of sandwiches. And 10 sandwiches would mean the shop would have to sell 50 waters. So there's a point right there. And then if we did 5 sandwiches, so 5 times 5 would be 25, and we would need $75 in waters, which is 75 waters. And so 5 sandwiches, 75 waters would be this point here on the graph. Okay, and we can continue. I'm not going to go too much in detail with how I'm getting these other numbers. Okay, go ahead and kind of work out the math, and you should see that 15 sandwiches means that the shop has to sell 25 waters, which is here. 20 sandwiches is 0 waters. And 0 sandwiches means 100 waters need to be sold. So one thing that needs to be thought about here is if I connect this line, or can I connect this line? Is this discrete or continuous? And so if you were in class, I mentioned that one way you could communicate to me or to somebody that you know whether it's discrete or continuous is to just write it, because if this is definitely discrete because we can't sell parts of sandwiches and parts of waters, so we're not using all real numbers here. But I went in 5s, and really we could sell 1 sandwich. It's hard to accurately mark 1 sandwich on here though. 1 sandwich would mean 95 all waters are going to be sold. So I'm going to do something like if you did a solid line, that's fine, because especially if you've written discrete, but I'm going to do dashed to say that we have some extra values in between. It's just not all of them. It's not all real numbers. Okay, and that's going to be the end of this lesson. Thank you for watching. I hope it was helpful. Please continue to come in and ask me questions, come into tutoring, do what you need to do. All right, have a good day.